So the quote Carrie there, she just said multiply straight across. If you want a little better directions for multiplication, you multiply the numerators and multiply the denominators. With this caveat that we always reduce if possible throughout the whole chapter, unless it happens to say for some reason it wants you to build something. So our usual goal is to reduce when we're done. So that top one we get 20/21. And as fractions chapter goes, this is the easy one because it's exactly what you probably thought would happen. For the second one, we get 6, 50 times 6, 300, 6 300ths. So even if there's 3 fractions, it doesn't really affect our decision making. We multiply straight across. The second one, can it reduce any? Okay, I see that they're even. So what I usually do is pull out 2's when I see that they're even. You might see that they have 6's in them or 3's in them. All that would work out quite nicely. Now I see that they have 3's in them. And I get 1/50. There's a good little introduction to the chapter. I already went through it where they draw a picture explaining why multiplication works. I'm not going to do that again. But I am going to show you a recommended shortcut. Some of you might remember cross canceling.
When it goes into the equal?
So as Rachel said up here, for stuff that goes in equally, I'm going to use the word common divisors. And so if we take that same problem that we just did, we can save ourselves some work. What do 3 and 6 have in common?
3.
3 and 6 have 3 in common?
Yeah.
It happens to be that same 3 that we dealt with up there. But if I deal with it earlier, I'll have smaller numbers. And what most of us probably learned how to do this as is you cross it out and put the answer of the division. Questions on that? Is that ringing any bells? There's another one that Mike's saying, the 10 and the 2. Because the 10 and the 2 are in a numerator and a denominator, he's saying that we can cancel that. It's the same 2. It was right here. You can do it later or you can do it sooner. The advantage of doing it sooner through your homework is you go through the homework a lot faster. You're canceling out those common things. And we get, after we multiply straight across, that exact same answer we got a minute ago, but I think it was easier. So here's another example. This is example 4 from page 223 in the chapter. It's 5/8 times 4/5. See any cancellation?
Yeah, 4.
Both of those have 4s in it. Some other people are seeing that both of those have 5s in them. You could multiply straight across and then deal with those.
1, 1, 4.
Cancel them both. Cancel both of Mike's 5s. And you get a half. Let me show you how the book did it.
Does that always work on all of them?
For multiplication, you can always cross cancel. Same problem from the book. The book wants to show us how and why it's working. I think that almost makes it more complicated in a way. What they did is they pieced apart the numbers that were prime. 4 is made of 2s, 8's made of 3 2s.
That's just confusing.
And they thought of canceling those common factors.
Your way makes more sense.
And most of us learned it my way. See that? I think that makes it harder. So when you're reading the chapter, you're welcome to do it that way. I've had a few students like that because you can really see where things are coming from. But these 2s and 5s that they canceled right there, there's the 5, and there's how we canceled it. And 2 times 2 is 4, and there's the 4, and that's how we canceled it. So you'll get a chance here in a minute to practice this. I want to try a couple others. What do you do when a regular old-fashioned whole number comes into play?
Put 1 of them.
Improper fraction.
It does make it improper. We'll talk about that. But for now, what Mike's saying is put a 1 underneath it. So when you have a whole number and it's involved with other fractions, you can create a fraction. And I would do this as I copied the problem down out of the book automatically. Those two don't have anything in common. In 1s, there's no reason to pull anything out of 1s. They just have 1s in them. So what's our answer here?
1 and 2 equal 1 and 1 half. 1 and 1 half.
You're welcome in this chapter to leave them improper. What is 3/2? What makes it improper?
Because the numerator is bigger than the denominator.
And then here at the end, I'll talk about how to go back and forth. But some of you are trained to change them to mixed so much that you do it automatically. We'll keep doing that. That's fine. So you have to simplify. You don't have to change to improper. And actually, in Math 60 and 65 in algebra classes, we prefer 3/2. So I actually just like it just like that as 3/2. What's that? Depends on the term. Depends on the term. And I can tell you what I'm doing summer. Not teaching. Here's example 5. Two things about this one. they wrote their multiplications with parentheses, but those parentheses are bumped against each other, so it's still multiplication. And it has sign numbers in it. It has 1, 2 negatives. And with multiplication, what's the final result when that happens? It changes to a positive. So that 1, 2 negatives there change to a positive. Throughout this whole chapter, they're going to mix in sign numbers. Some of those will get kind of difficult. Some of them are just plain simply good practice. I'm going to cross off. It's the one I saw first. A 2 that was in the 2 and the 10. You see others?
Yeah, the
3 and 9.
The 3 and the 9.
7, 14.
And then,
Say,
Yeah.
you don't have to do one with the expression.
Remember, there is nothing in parentheses really here. There's no, the parentheses are implying a multiplication. The parentheses are not asking us to do something inside of them. There's no terms or adding or subtracting in the
Why are
parentheses.
they in parentheses?
It's a common way to show multiplication, and it's most common when somebody's negative, so that you can see the negative in there.
Okay.
And those two?
7, 10.
So I get
1, 1,
You get 310?
3/10, and we already talked about, hey, that's positive. Kind of randomly thrown in here is the area of a triangle formula. We'll have a whole chapter where we really get into area and perimeter. The reason it's thrown in here is because it has a fraction in it with multiplying. In this particular one, example 8, we're going to figure out close to what the area of Virginia would be because it's close to a triangle. And where the half comes in is if Virginia had been a square, it would have been twice the area, so you have to cut it in half like it was a triangle. You don't know anything about area at all at this point, except for take the two numbers, and we're going to go 1/2 times one of them times the other one of them. And that's what every homework problem about area is actually about in this chapter. We're not going to show it like the book does. Notice that they did that, breaking it apart and canceling it. We're going to show it with my shortcut. So what did we say earlier about when I have a whole number involved?
Turn it into a fraction.
Change it to put a 1 underneath it.
Also,
Yeah, this is the one that I see.
yeah.
And then a good review when multiplying by
Right on.
hundreds, thousands, tens. What's the quick trick to do this multiplication without writing it out?
Add the zeros.
Add the zeros.
Yeah.
There's 2 zeros. Let's just get added on the back. All those little tricks are in the optional chapter on multiplication that you're supposed to kind of know. You don't need to know every trick, but they certainly are helpful. So I put 2 zeros behind the number.
That only work in hundred.
Yes. Yeah, you don't get to use a shortcut unless 3 zeros.
Okay.
They labeled it, and this is a book problem, they labeled it square miles. You don't need to be an expert, but I'd like to just quickly talk about that. What in the world is a square mile?
Like when you're doing carpeting, you know, like square foot. You kind of have an idea of it.
Yeah, it's the idea of an area. What a square foot is it's a 1 foot by 1 foot tile, and you're saying how many 1 foot by 1 foot tiles fit in there. A square yard is about what the soundproofing tile is. Those are about a yard, and they're about almost exactly 1 yard by 1 yard, so we can figure out the area of this room in square yards. And a square mile is a 1 mile by 1 mile square farm
Right.
out in the Midwest. And that would be a square mile. And you've heard that before on the news. So it's something to think about. If we get time, week 10, we do area, perimeter, volume. If we don't get time, you see it in Math 60 again. What do I really want? Just to be able to plug it into this nice formula and get used to it a little bit. So I want you to do some practice now. I didn't put any signed numbers on any of these. I won't do a whole lot with signed numbers today. As you work through your homework, if I can get your attention, as you work through your homework, it'll start with regular old-fashioned numbers and build you up into some signed number practice. So I expect to have lots of questions on the signed number ones, but these are all positive. You could multiply straight across. You'd get a fairly large number on this, and you're going to save yourself some time on the homework if you look for cross cancellations, such as the 4s. I specifically set this one up. You can either go with the 3 and the 9, or the 3 and the 3, but not both. Go one at a time, carefully and slowly. So the 4 and the 8, not much choice there if I want to use cross cancellation. I think most of you probably went with the 3 and the 9. Because of that, I'm going to do the other one and see if we get the same answer. So I went, one's in the numerator, one's in the denominator, and I went across and canceled those two. And we should get the same answer. I got a 2 in my numerator, and I got a 9 in my denominator. I got 2 9s.
Yep.
Questions on that? And the second one was set up to just create caution. Can I do any cancellations?
Yeah, 4 and 2. I mean 4 and 10.
Yeah. The 4 and the 10 are fine. How about the 5s? Do they have a comment on that?
4 and 10.
So what do 4 and 10 have in common?
Oh, I guess
2. Now you could find that out later, Colin. If you multiplied straight across and got 4/50ths, then you could reduce it. Or as Mike's saying, we can do it right now. Sorry, 2/25. I guess what I was asking.
Are you dividing by 2?
Yep. So they're both even, so we divided them both by 2. It might help you in the Learning Center. It helps some students to actually write out a quick little note to themselves so they're dividing both by 2. Okay. I just wanted to make sure We didn't cancel the 5s. They're both in the denominator. And the caveat was they had to be in the numerator or denominator. Yeah, Blanca?
Well, this is okay, right?
Our directions here, it's a good question. In this entire chapter, unless it specifically says, everything will be followed by reduce if possible. Question? Okay. Find the area of the triangle. In the particular homework that you're given, there'll be no trickery in this sense. The two numbers are the two numbers that we want. In upper level, they might give you other numbers and you got to pick which ones are appropriate. At this point, a number and something right across from it will be given, and those are the numbers that we're going to put in, the base and the height. Any cancellation?
Yeah, 2 and 6.
You could do that now or later. Everybody should have got 21.
So, how do you say that when it's 21? 2 times the 3 into the 6 into the 3.
And then it's multiply straight across. 3 times 7 is 21.
Don't reduce the 7.
And
Oh.
ones. But
You don't reduce the 7.
there's nothing to reduce it against. There's no common multiples in the denominator. Okay, Carrie had one question earlier. She knows the shortcut for writing square feet. If you know it, that's fine. I like to shy away from it because it makes me think of exponents, which there really is nothing to do with exponents here, but ft with a little exponent of 2 is the shortcut for square feet. Okay. One last example, then we're going on to division. What does that little exponent of 4 mean?
Negative 3 so far.
So they're saying it's the whole thing though, but negative 3/2 times itself 4 times. Is that going to be positive or negative? One, 2, 3, 4 negatives. Odd or even? Positive, because it's an even number. Three times 3 is 9. And 3 times 3 is 9. And 9 times 9 is a total of 81. Or I could write down some work about how I figured that out. And then be careful with the 2's. There's a tendency to take one too many, so I'm going to count out just like I did the negatives. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And again, unless it specifically says you do not have to change it to a mixed number, I actually want that answer. I want to stop right there. If you did change it to a mixed number, that's fine. You do have to reduce if possible. They're different things. Okay, here's the book's direction for dividing. For multiplication, we drew a little picture and talked about how it worked. If you want to find out why division works, you got to come talk to me in my office hour or the Learning Center, because we're just going to view it as a rule. Every time I've tried to show it in class why it works, it doesn't help anybody. Turns out the rule, as written in the book, might be a little bit hard to remember, especially since it has this word reciprocal. But you'll never hear me explain it like the book does as we're going through it. And you maybe have heard this before. To divide, flip, and multiply. And that's the way to remember it. And turns out that's really, for us, a good enough synonym for reciprocal. Reciprocal means flip.
The way that my last teacher said was keep it, change it, flip it. So you keep the first fraction, change the division into a multiplication, and you flip the second fraction.
I do like that. If I could spell change, that is.
Close enough.
So from Rachel here, another way to explain it is keep it, change it, flip it. And what that means is keep 3/4 as is, change the division to multiplication, and flip that fraction. Actually take it and flip it over. So you got 2/3. What will happen if I flip 2/3? 3 2s. Keep it, change it, flip it. And I picked this one on purpose. Don't cross cancel until you keep it. See, I don't have to memorize that. Keep it, change it, flip it. Because no longer is there any cross canceling. Is there any common things in a numerator denominator where we can cancel out common divisors?
No.
So we just multiply straight across and get 9/8.
You wouldn't reduce it?
You can't because they're
No,
not.
I'm talking about this, you're talking about the final answer.
So it is a little bit of a hard thing to explain, but that is already reduced.
Oh, okay.
But you want to do something, and it's a good thing to do if you know how to do it. You want to change it to,
Improper fraction.
and what would you say it is as an improper fraction? Or a mixed number. It is improper, I know. It's 1 1/8. That's different than reduced.
Oh, mixed.
That's changing to a mixed number.
Okay.
And that is optional. Unless, as it happens for just a couple of problems, unless it tells you to change it. And what I mean by reduced, for those of you that don't see it, 9 and 8 have no common divisors. There's nothing on the multiplication table that would want to come out of those. That's it. That's the chapter. That's one whole chapter clicked off. If you keep it, change it, flip it, you get a whole bunch of multiplication practice. There's one to remember. It doesn't change anything from what we've talked about before.
Thou shalt not divide by 0.
Thou shalt not divide by 0. So this one is undefined. End of story on division, to be honest. Those of you that missed Tuesday, we did a lot of practice that's going to help us in this chapter. Right, and those of you that are here, you can either recognize these problems that I'm going to look at or pull out your worksheet. And the first one we're going to look at here is number 7. Growing up on the farm, I always mixed up the 1/8 and the 5/32 wrenches. And you really only need to pull these out when you're working on super small things like a motorcycle. And really what I was trying to decide was who was the smaller wrench and who was the bigger wrench. And in terms of math language, which one, the great math language, which one's Pac-Man 1E? There's no official math language there. And I really don't know unless I have it memorized, or better, unless I build them. We've been building for a while now, and I've been trying to really focus on it. But not everybody has it down yet, because it didn't really matter until now. In 3-4, we need to look at common denominators and really compare things. And the way I build stuff is I use my multiplication tables. Most of these problems will fit right on a 15 by 15 multiplication table, not all of them. And I multiply the top and the bottom by the same thing. So now 1/8 is equivalent to a 4/32. It's not what's written on the wrench, but it's what it is. It's 4 out of 32 spaces. Which is bigger? Now I can pretty quickly say that 5/32 is bigger. That 32 came from, in English, your commons, or your most common, are 4, 8, 16s, and 32 in English measurement. And as a lead-in to something we'll look at after the break, that 32 came because it's the least common multiple of the denominators. Sometimes called common denominators. Usually called common denominators. You see that? So another more difficult question on there was number 8. They gave us a whole bunch of wrenches. 3/8 and 7/8. Which one's bigger?
7/8.
7/8. It's bigger. And that one was, I picked that one because it was easy, because they both had 8s. The other one that I often mixed up was 15 16ths and 7/8.
30, 32, 20, 30.
Yeah.
Okay, like you see 7/8 and 5/16. Would 5/16 be larger than 7/8 because of the numbers?
Or 15 16ths, right?
15/16 because I know 7/8 is one more for being a whole, which is 8. 15 over 16 is one for being a whole.
Here's how we decide. If we're just looking at those two, change them both to be out of 16. And it turns out the 15 16ths is the bigger wrench. It's just a little bit off of being a whole inch. And then Rachel's idea for this one, I'm not going to do this, but Rachel's idea, if I really want to get all these figured out, I could change them all to 32s.
That's what we did.
Okay, so that was kind of a hint on number 8 on there. Most of you already did that one. Something to think about. The other one I want to look at before the break is number 11 on that worksheet. I don't really know where this came from, but my little brother decided that he's going to get into gold mining. After about 8 years of doing it, he showed me his little vial of gold. I don't think that he's ever even gotten up to 7/8 of an ounce over 10 years. It's more of a hobby than anything. He's the only one still working on the farm. And actually, he just started school last week. He's going to lineman school on the coast. So he's similar to you all, just starting school. And lineman school is electrical school. You work on the electrical lines. So.
Where's your farm?
What?
Where's your farm?
Sublimity. It was supposed to be called Sublime City. And then when they sent the stuff to the post office, they lost some letters, and it became Sublimity. This is a true story.
Is it Oregon?
Yeah, it's near Detroit. And it's Silver Falls. You know where Silver Falls is? Yeah. I used to ride my dirt bike to Silver Falls. Anyway, as a pretend question, back on track. If Zach has 7/8 of an ounce, and he's his own guide, but just for pretend, if he takes 4/8, or what does it say in the problem? 3/8? If he takes 3/8 of an ounce and gives it to me, which he ain't gonna do, is that add or subtract if he's giving it away? And then almost everybody, I didn't explain this one at all, by the way. Almost every group was able to figure out what to do. What do you do on that?
Subtract the numerators, the denominator alone.
So again, in Rachel's words up here, it's subtract the numerators, leave the denominators alone. I'm going to add to her words, simplify. Is there any simplifying that happens in this one?
Divided by 2.
And if you do that, you could divide it by 2 again.
Yeah.
So Zach has a 1/2 ounce left. And you can see that works. If I cancel off there on the picture the 3/8 that he gave to his guide, you can see that there's a 1/2 of the vial left. Any questions? My family's riches, not that we're rich at all, but it doesn't come from gold, as you can see by my brother's lack of 10 years of getting anywhere. We used to have a farm in Oklahoma way back in the day. Great-grandpa sold it, but he kept the mining rights. which there's oil there. So every once in a while growing up, a little check would show up in the mail. Not very much because it goes to so many people, but it's how we made our double wide into a double wide with a little addition beside it, and then slowly over time. That's not riches, in my opinion, but I'll leave that to you. So the book, let's just read it. It's on 242. I like the way Rachel said it, but it says to add or subtract fractions that have the same denominator, add or subtract their numerators, write the sum over the common denominator. They're essentially saying the same thing that Rachel said. Add or subtract the numerators, keep the denominators the same, called the common denominators.
What if they're different?
That comes after the break. Okay, to repeat Skillful's question, again on the first one, was there any questions? Subtract straight across, then simplify. Skillful's noticing that something is going on in this one, and particularly that it's involving positive and negatives. It turns out in this chapter that change is still alive and well. Anytime I have positive or negatives, I want to change it to adding the opposite. And what that's going to look like here is add the opposite. And what that's going to help you with is that 2 and negative 4 are enemies. So we still subtract them, but you get a negative out of it. It's negative 2/3.
But if you know how to just do it across, you have
Yeah.
to change that?
No. Jarena, the change is always optional. It's just helpful. I bet even you do it for some of the longer problems, though.
Yeah.
But certainly on this one, a lot of people could just do that and know it's negative.
Okay.
Question on that? Then the next one had another thing kind of set up here. You do add straight across. If you got that, that's great. There's one more thing you could do. And fractions are really just divisions. 10 divided by 5 is what? 2. You can make it 2 over 1, or I'd really prefer it be just 2. Any questions on that?
So I just reduce it to 2?
Just reduce to 2. If you brought your book, the directions are on page 245.
Wait, I have a question. Why don't you add the 5?
And Anna, it's right here. When you add or subtract, you keep the common denominator. In that picture I showed with my brother, just to show you, I'll bring that back up in 2 seconds. When he had 7/8 and gave away 3/8, it's giving away 3 of those pieces, leaving it with 4/8. So there's the directions. I'll give you a little bit of time to write them down there. So pretty close to exactly what it says on page 245. To find the least common denominator, or do find the least common denominator. Remember that whole section on LCMs? That's for these next examples. We're going to be finding LCMs and building fractions all over the place. We find the LCM, we build the fractions, add or subtract the numerators and keep the denominators, as what Anna was asking about. You keep the denominators the same in this chapter, and then you end by reducing. And I've been trying to build to this over the last whole week, actually. Last week we looked at fractions and building them and reducing them. We've been comparing wrench sizes and saying that the best way to compare them is if they have the same denominator. And then I got to flip the page, so I got to give you a second to keep writing. Some people are still writing here.
You said it's in the book.
It is in the book. here's what I'll do. I'm going to do one example on the... Oh, I got a little space here. I'm going to do one example right above it to give people some time. So this is example 4. Again, on page 245. And they want us to go 1/7 plus 2/3. And they don't compare very nicely. They're not good friends, 1/7 and 2/3 for adding. Most of your problems, you're going to look on your multiplication table. Where did I go off? 12, 15, 18, and 21. I guess Shane needs a multiplication table. On most problems, you're going to look on your multiplication table or write out a multiplication table, which is what I just did. And your LCM is going to be the first place that you see that they're in common. Rachel here is saying it's 21. 21 is the first place that 3 and 7 are in common, the LCM. The other way to do it is do the factor trees like we've been practicing to find the LCM. Alright, it wouldn't be very interesting on this one because they're both prime. So 3 times 7 is 21. Here's how I do it. I state my goal, and my goal is to have both of them be out of 21. But I build. You said 3 times 7, Mike, there. That's how I get 21. I want to also build the numerator. So I multiply the top and the bottom by 3. So 1/7 is the same fraction as 3/21. Questions on that? That's the big thing. This is probably the most difficult thing for students in the whole chapter.
So the 2, why didn't you do something with the 2?
We got it now. So 3 times what gives me 21? So I have to be fair to both the 3 and its incorporated numerator, the 2. And now they're much more friendly fractions. Like my brother's example. Add the numerators. And keep the denominator. 17/21s. I'm not going to do a whole lot of these. I'm going to do about 3 or 4 of them, and you're going to do a group activity. But that's how it works. So I'm going to do a couple more. Any questions on that one? So I added the numerators and kept the denominator. In order to keep the denominator, they had to have the same denominator. I had to build an LCD. Build a least common denominator.
So when you first see a problem like this, you always do the bottom part first?
Yes. And now look at this directions. Right from the start it says, find a least common denominator and build it. That's where you start. It's finding and building. On your examples over the break, there was no finding and building because they were purposely already had common denominators. Other questions? Let me give you another example. Questions on this one?
Yeah. I'm kind of confused. Like, I see what you multiply the 3 times 7, but if you got 21, do you always add the top number and always multiply the bottom?
So when I'm building, I still multiplied both of the numerators. I thought about what they needed to be multiplied and I changed them or built them. But once I've built them, I think this is where you're looking at, then I do add them up like it's asking. Let me do a second example.
Wait, did you get the 21 by email? How'd you get the 21?
That was up here. And if you want some practice, that was section 1.9, I believe. The whole reason for that section of finding least common multiples, 1.8, was so that you'd have some practice here, but you might want to go back and look at that homework. Okay, let me do another one, and it'll help. Let's do a 5/6 plus 3/8. So there's two ways to find the least common denominator. One would be listing or looking at my multiplication table. And looking for the first place that they have something in common, like 24. Another way to find least common denominator is to make a factor tree. And it's always the highest exponent on each. So there's 3 2s and a 3. 2, 4, 8, 24. Almost all of yours will have smaller numbers that the multiplication table will work just fine. So this actually works for 99% of what you're going to be doing. Questions on the 24. That's our starting spot. That's step 1. It's just finding the 24. Step 2, the way I do it, and there's other ways, and if you remember some way that you learned it in the past math class, stick to it, it's fine. The way I show it is I write my goal, which is to have both of them be out of 24. And to make that goal happen, I think about how to build. 6 times what is 24? 4. And that also would come here on my multiplication table. It's the 4th row. Or whichever way. It doesn't matter which way you look at it. And so, I just need to remember, this is the main thing you got to remember. If I'm going to build it, I got to build the numerator and denominator. We've been talking about that since exactly a week ago. You have to multiply the top and the bottom. And 8 times what would give me 24? 3. I got to build the top and the bottom the way I show it. Is by adding the common factor of 3. I'm out of room over here, so I'll write it down here. Add the numerators, keep the denominator the same. It's already reduced, so it's optional if you want to go to where Carrie went. Where Carrie went is it's 1 and 5/24. We might as well mention that now. Carrie wants to, through years of training, as some of you do, she wants to change it to a mixed number. A good way to record what she's doing is she's doing long division in her head, actually. She's saying that 24 goes in there once. With the remainder of 5. So the whole number is the divisor, And the remainder is the leftover numerator. And she can just do that in her head on that one. So it's optional to go to that level.
In 60 or 63 or 65, will it be?
Here's what Rachel's asking, sorry to cut you off. In 60 and 65, in any algebra class, we like improper fractions. We keep them improper. And hence, you'll notice we're skipping a whole bunch of chapters in here about mixed numbers. But for good reason. They're good for rulers, though. All right, one more example, then you're... Oh, no, I'm done.